Hello students, in this video we are going to discuss the solutions of 1.19, 1.20, 1.21. A point charge causes an electric flux minus 1.0 into 10 power 3 Newton meter square per coulomb to pass through a spherical Gaussian surface 10 centimeter radius centered on the charge. If the radius of the Gaussian surface were doubled, how much flux would pass through the surface? What is the value of point charge? Here the data given is electric flux. The electric flux is equal to minus 1.0 into 10 power 3 Newton meter square per coulomb. Here the flux given is negative. That means the flux is entering into the sphere. What we need to calculate? If the radius of the Gaussian surface were doubled, if the radius is doubled, what happened to the flux? So the flux will be remain same. The flux is equal to minus 1.0 into 10 power 3 Newton meter square per coulomb only. That is remains same because it is independent of radius, and the charge enclosed is the same value in both the cases. So in this formula actually phi is equal to q by epsilon naught. It depends upon the q. Coming to part B. What is the value of point charge? From Gauss law, electric flux is equal to q by epsilon naught. From this q is equal to electric flux into epsilon naught. So this electric flux value is minus 1.0 into 10 power 3 and epsilon naught value. For our simple calculation purpose, I am writing it is 1 by 4 pi into 9 into 10 power 9. How we got this? Actually we know 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. From that epsilon naught is equal to 1 by 4 pi into 9 into 10 power 9. Like that we are getting it. So after simplification, we will get this is minus 8.84 into 10 power minus 9 coulomb. This one also we can write minus 8.84. 10 power 9 can be written as nano coulomb. So the charge is negative. That's why the flux is inverse. Coming to 1.20. A conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 1.5 into 10 power 3 Newton per coulomb and points radially inwards, what is the net charge on the sphere? We can imagine this is the sphere of radius 10 centimeter. Some unknown charge is present on this one. At distance 20 centimeter from the center of the sphere, here the electric field value is 1.5 into 10 power 3 Newton per coulomb. Now we need to find out the net charge. Actually, the electric field due to charged sphere E is equal to 1 by 4 pi epsilon naught into Q by R square, where R is small r is this 20 and capital R is but the radius of the sphere you can assume. From this, Q is equal to E into 4 pi epsilon naught into R square. So this E value we have 1.5 into 10 power 3 and 4 pi epsilon naught value we can write 1 by 9 into 10 power 9 because 1 by 4 pi epsilon naught value is 9 into 10 power 9. From this 4 pi epsilon naught value is 1 by 9 into 10 power 9. Instead of writing 4 pi value epsilon naught value, it is easy to calculate. Into radius square. The radius is 20 centimeter. We can write in terms of SI 20 into 10 power minus 2 in terms of meter whole square. After simplification, we will get this value is 6.67 into 10 power minus 9 coulomb. We can write this one is 6.67 nano coulomb also. This is the charge actually, but here we have calculated the magnitude of the charge alone. Here the electric field is radially inverse. Electric field is radially inverse. That is possible only if the charge is negative charge. So as the field, electric field acts inverse, the charge must be negative. So finally, the charge Q is equal to minus 6.67 nano coulomb. So this is the answer. So direct formula E is equal to 1 by 4 pi epsilon naught into Q by R square. From the Q we are calculating. Coming to 1.21. A uniformly charged conducting sphere of 2.4 meter diameter has surface charge density 80.0 microcoulomb per meter square. Find the charge on the sphere. What is the total electric flux leaving the surface? Coming to the solution, we can imagine that there is a charged conducting sphere like this of diameter 2.4 meter, means radius is equal to 1.2 meter. The diameter is 2.4 meter, then radius is equal to 1.2 meter. Has a surface charge density sigma is equal to 80.0 microcoulomb per meter square. We can write it is 80 into 10 power minus 6 coulomb per meter square. Now coming to charge on the sphere, we have the surface charge density. So therefore, from the formula of surface charge density, sigma is equal to charge per surface area. Surface area of the sphere is 4 pi r square. So from this, Q Q is equal to sigma times of 4 pi r square. Sigma is 80 into 10 power minus 6 into 4 pi. Radius is 1.2 meter. So 1.2 whole square. So after simplification, we will get 1.45 into 10 power minus 3 coulomb. 10 power minus 3, you can write milli also if you want. We can write it is 1.45 millicoulomb. This is answer for A. While coming to B, what is the total electric flux leaving the surface? From the Gauss theorem, we can write electric flux is equal to Q enclosed divided by epsilon naught. From this, we can write Q is nothing but 1.45 into 10 power minus 3, and 1 by epsilon naught value is 4 pi into 9 into 10 power 9. After simplification, we will get 1.6 into 10 power 8 Newton meter square per coulomb. So this is the electric flux coming out from the Gaussian surface or leaving the surface of the sphere. So these are the solutions. In the next video, we are going to discuss the remaining two also. I hope these solutions are useful to you. If you like it, please subscribe and share and comment. Thank you.